So to set the right expectation for this presentation, we will briefly introduce you to two different but complementing technologies. The first one, artificial intelligence, or more specifically on one of its branches called generative AI and data streaming platforms. So artificial intelligence has transitioned from being a niche concept to a widespread force, right? Shaping the landscape of the business world. So in this era of digital transformation, the integration of streaming and AI has emerged as a crucial driver, focusing on the dynamic and real-time facets of data flow, to generate contextually relevant predictions. So business, across diverse sectors, are increasingly adopting AI technology to optimize operations, stay competitive, and augment user experience. However, the true power of AI unfolds when applied to the right data set at the right moment and within the appropriate context. And by the way, keep in mind this word context, right? Because we'll come back to that later on. And you're going to hear this word over and over in this presentation, context. So it's an important part of this presentation. And we'll see, how both technologies can work together, so you can provide a better, and richer experience to your customers, or how to augment generative AI applications by bringing to them the latest and freshest data, be it about your customer, your business, the market, etc. And at the end of it, as Chris said, we're going to have our Q&A session. But feel free, to write your questions on the chat or any comments you have on the chat, and we'll get back to you on the presentation. So let me lay out a couple of concepts relevant, to this presentation. The first one is data as a product, or data as a first-class citizen. So the transition from viewing data, as a byproduct, to treating it as a first-class citizen, right? So this transition represents a shift on how business leverage technology, for strategic advantage. So initially, data was basically an input and output of applications, such as a client server REST API interaction, where the primary focus was on the functionality rather than on the data itself. As technology and business strategy evolved, the emphasis, shift towards, data-centric architectures. So modern applications, for example, apps, producing events, directly to streams of data, they prioritize data generation with quality and real-time processing. So these platforms, they enable continuous data ingestion and analysis, transforming data from a simple, byproduct into a core asset that drives decision-making, operational efficiency, and innovation. So this paradigm shift not only enhanced the value derived from data, but also catalyze the development of more intelligent and asynchronous but responsive systems. And when data is produced without prioritizing data quality, it can often lead to inaccuracies and inconsistencies that might erode trust to the ones consuming it. So this lack of reliability, can result in end users or clients choosing not to consume the data, thereby reducing its perceived value. So without trust in the accuracy or the relevance of the data, its utility it's reduced. So the stakeholders are less likely to have it integrated in their decision-making process. Just like any other physical product. For example, why would I buy a car from a manufacturer that doesn't produce reliable cars, right? So this physical world and data worlds, data as a product, they are very similar, right? In the way you handle data as a product. So when data is treated as a first-class citizen, data quality is paramount. So that's something, to keep in mind. If you're talking about data event-driven strategy, you need to think about your data quality strategy as well. So the second set of concepts, now it's about AI. So, and by AI, I mean artificial intelligence. So I might be saying AI over and over in this presentation, but by that I mean artificial intelligence. So the first one is machine learning, right? So as you can see here, a broad field of artificial intelligence that involves the development of algorithms and models to allow computers to learn from data. So the primary goal of machine learning, it is to enable systems to improve the performance on a task over time without being explicitly programmed. Second one, generative AI. It's a category of artificial intelligence, that have the ability to generate new content, such as text, image, or videos, or other data types. So these systems can create original output rather than just primarily classify or analyzing numeric data, for example. Third one, large language models, or just LLM, right? From now on, when I say LLM, I will be referring to large language models. So they are generic models that are trained on extensive data sets to understand human-like language. So, LLM is a general term, right, that can encompass various types of large-scale language models, and including but not limited to, GPT, right? GPT stands for Generative Pre-trained Transformer. So it's a specific type of generative AI model, and GPTs, this pre-trained massive amount of data, as we said here, and then fine-tuned for specific tasks. And that model was developed by a company called OpenAI. And I think ChatGPT it's one of the most well-known applications using LLM or using the GPT model. And sometimes people use the term ChatGPT as the actual model or describe the entire model of large language models. But it's just an application using the GPT model. Now, let's talk about AI for a minute here. So you can classify AI, let's say, in two approaches, right? The first one is predictive AI, which is a broader concept that involves the development of algorithms and models that allow computers to learn patterns and make decisions or predictions without being explicitly programmed for the task. But there's a one-to-one relationship between the trained model and the use case, right? Or the trained model and the application. And this has been, the standard approach until the rise of generative AI. So the generative AI, on the other hand of the scale here, it's a specific type of machine learning model designed to understand and generate, human-like language. These models are particularly trained, as I said, a massive amount of data. It could be, books, articles, websites, now even, videos and audio materials. And primarily, they try to identify patterns and the structure of the natural human language. So it allows, those models, they understand context, they understand grammar, semantics, and even generate very coherent and contextually relevant content. So the LLM permits a one-to-many relationships between the model and the use case, or the model and the applications. So in that generic form, they can also generate, new text based on a prompt or a topic, like, for example, how to make bread at home, or, give me some ideas for my next, adventure book. But predictive AI and generative AI, they are related concepts, but refer to different aspects of the fields of artificial intelligence. And now in this, they see these purple bubbles there, data engineering, prompt engineering. So very briefly here, in the traditional machine learning, Data engineering predominantly, happens during the creation of this purpose-built model, right? It's shaping a specific data set for a singular, task-specific model. And this paradigm shifts with large language models, right, or LLM, where a generic model is constructed, right, using, these data sets, using deep learning technologies, which result in this broadly capable and reusable model. And prompt engineering here taken a center stage because it's an important mechanism for tailoring the questions or the prompt when interacting with the model, right? So what do I mean by that? So LLM models, they are powerful, but they cannot read our mind, at least not yet. So prompt engineering or prompt assembly is something done at the runtime or the application level, where additional context it is injected into the question or the prompt, right? And again, I keep saying, the word context. As I said, we're going to see that more and more. And at the end of the presentation, I didn't mention in the beginning, but we're going to have a demo as well, where we'll see in real time, how to inject or how context is injected into the prompt. And so just coming back here to predictive AI, it's statistical models, for forecasting, outcomes, right, based on patterns or historical data. And the coupling between the application model, they are very high. And on generative AI, that coupling is very low because it's a very generic and reusable model. For example, on predictive AI, I can predict, my how the sales, right? How my sales, how I'm going to do sales wise the next quarter, or next week, or next month, whatever it is that the model was trained to. And generative AI is very different. That was an actual question or prompt. I submitted to ChatGPT. I said, no, please write a poem about the future. So ChatGPT was able to understand that. So, okay, it's a poem, it's about the future, and come up with, that answer. If it makes sense or not, if it's going to win the next, literature prize or not, it doesn't matter. But it was able to understand, what I was asking, and just using natural language. In the presentation today, I'll focus mainly on generative AI. So let's see one example here, right? So let's say I have my LLM model was trained, is there, waiting, to be used. I have built a chatbot application, and I have a customer, coming through and accessing my chatbot application. And my customer will say, I'm a very wealthy and important customer. Can I apply for a loan? Okay. My chatbot application will send exactly that question to the model. And the model, is based on unstructured, data, and will provide an unstructured answer. And basically, the model is saying, okay, you are saying you're a wealthy customer. I do not know who you are. I really cannot assert if you are, a wealthy and important customer, as you say, and you want to apply for a loan. But what we want to do? We want to buy any product or services. I do not know what kind of interest rates the company you want to apply for a loan they have available. So it's you see, it's a very generic and I can say a useless answer, right? And is the model wrong? No, absolutely not. There's not a problem with the model. But the question of the prompt is massively, lacking context, right? It's lacking information about the customer, about the company. And how is that helpful? Is that any helpful to my business? The way it is framed here, absolutely not. But not to despair, we're going to come back to that with a more contextually, with more data to actually, make a better user experience. Because the way it is here, I wouldn't come back to that chatbot again ever. Right. So we saw those initial concepts, about data as a product, AI. We understand a little bit more about predictive AI and generative AI. So now let's touch upon data streaming platforms. So first, what do I mean by data, right? Let's see one example here. So we're gonna data could be a digitized content that was generated in response to an event. An event could be a measurement taken, by an IoT edge device, a user action, session notification, a external signal, or purchase order, right? And the past occurrence, from the immediate past or not, it doesn't matter, but they always happen in the past. And usually, they have a payload and a timestamp, and they are immutable by nature, right? On an event-driven data architecture, the events, they are immutable. You cannot change an event. So for example, in the case of a purchase order, if I place a purchase order, I will need to first capture that moment in time. So anyone that needs to understand that event will be able to actually understand. So for example, on a purchase order, I'll have the customer ID there, the SKU of the product or the service, how many items I'm buying, the description of the items, the price and the discount applied, and of course a timestamp, right? But they are immutable. And I say, okay, but what if I cancel that order? Yes, that's another event. It's a cancellation event. So you have to treat those events as immutable. And if you want to override an event, you just create another event to override it. And once those events are stored, a secured store, it can be consumed by, diverse downstream applications, in a synchronous, seamless, and scalable and reliable manner. And again, to emphasize that point, on an event-driven architecture, data should be treated as a product or as a first-class citizen, right? So that meaningful event that whoever needs to consume that event will be able to understand, regardless of the application, regardless of the use case. And if we compare, let's say, if we see one event, right? One event is immutable and has happened in the past, as we said. But we can actually correlate an event to a fact, right? One event that happened is one fact, something that actually happened in a specific moment in history. And when I have a series of events, and when I have them chronologically ordered, it can tell me a story, right? So an event is a fact, a series of events is a story. And that's a very powerful context in our data stream platform, because I can not only store, but I can also process, but also reprocess and replay those events. So I'll give an example here. If you are in a battlefield, and every single one of your troops or your tanks or your equipments, they have a sensor, or they're able to capture every single move you make, every single action you take, every single round of you shot. If you're able to catch all of those moments in time, you can replay the whole history of the battle, either for the reasons I won or the reason I lost. You can actually replay and see all of that coming through into time. So that is the advantage of a data stream platform, not only to capture but also to replay those events or retell the story. And a data stream platform plays a crucial role in, for example, data fabric, data mesh, and event-driven data architecture. So it empowers business to respond rapidly to emerging trends, make informed decisions, and enhance overall operational efficiency in increasingly fast-paced and data-intensive environment. So it's a robust and dynamic infrastructure designed to facilitate the seamless real-time ingestion, processing, and sharing continuously flow of data in a synchronous and decoupled way. One of its ability, it is to publish and subscribe to streams of data. That's something that has been around for some time, like messaging systems or traditional pub/sub, and have, they're all able to do that. What's different now, as I said before, it is the ability to store data, right? And do that in a properly and distributed and reliable manner. And as I said, as well as the capability to process and reprocess those streams of data. So those streaming data architectures, have become a central element of Silicon Valley, technology, companies. Like, for example, everything, every stream or every data that happen in a business, like, for example, Uber, Netflix, PayPal, eBay, just name a few, it runs through a data streaming platform. But don't take me wrong, right? Data streaming platforms don't have to replace, for example, your data warehouse or data lake. In fact, quite the opposite, right? I mean, they feed data into it, right? It acts as a central nervous system that for data to quickly flow into a data warehouse environment, and then from there you can do longer term retention, ad hoc analysis, train machine learning models, and etc. But on a data streaming, all of that, right? When you connect to data, when you process data, and you share data, all of that at real time or near real time. So Apache Kafka is an example of a data streaming platform. Apache Kafka is an open source project. So it was originally developed by the founders of Confluent, the company I work for. It's it's an open source, but powerful and distributed stream platform, designed to handle real-time data streams, at scale. So we have these transactional and non-transactional events, flowing through the data stream platform. They get processed in real time, using stream process engines, for example, such as Apache Flink, for example. And at last, the process streams can result on, for example, a materialized view of the current state of your customers, providing, a 360-degree view, or go to live dashboards, or, even go to analytic systems, that's what you can do once the data is processed. And so, in other words, right, stream processing applications enrich, aggregate, and filter events in real time, in either a stateful or a stateless fashion. So basically, it manipulates data as it happens, other than waiting, to land in a data lake and only then, run a batch. So, for example, if you're getting GPS locations from assets and check in real time whether that specific asset is in a geofence and how long they stay there, right, in that geofence. So you can know that in real time. And that enables what we call the creation or the construction of data products, right, which can then be later consumed or directly fan out to other multiple systems. And in Confluent, we offer more than 100 and I think now it's more than 200 fully Apache Kafka connectors that could be fully managed on Confluent Cloud or SaaS offering, or self-managed on Confluent platform, the self-managed version. And the connectors are what make it easier, to instantly connect, popular data source to and from Apache Kafka. And as you can see in the image, just to name some examples. In Apache Kafka and event streaming, have skyrocketed over the last decade, where 80% of the Fortune 100 companies, they are using Apache Kafka. Okay, excellent. So now we saw data products, generative AI, artificial intelligence, data streaming. So now let's see how the synergies between data streaming and artificial intelligence. So on the LLM model we saw previously, so generic questions will get generic answers. So we need to inject, contextually relevant data before submitting, the prompt or question to the LLM model. So fortunately, you don't need to learn some new programming language, or like when you have to learn SQL, to interact with database, or a new programming language, or have programming background. Because when you interact with the LLM model, you're using the language that you have been using your entire life, right? I mean, however, it's fair to say that a better communicator, you get better answers. So when working with LLM, you are starting effectively, at ground zero, right? You have this massive brain of combined knowledge sitting there, just waiting for your question. So when submitting the question to the model, the application that should know who your customers are, can inject or can add this contextual relevant data into the question. Like, for example, customer profile, status, age, address, preferences, or current, and past transaction and orders, as long as it's relevant, to the question, to the application that you are using. And where does that information come from? It could come from this materialized view, from your customer, 360-degree, So as you saw previously with the transaction, non-transactional customer data flowing through a data stream platform, you can have that materialized view serving your applications, and always want to have the latest and freshest information. But however, to fully harness the potential of large language models in a business context, the scope extends beyond just customer-specific data. So, for example, consider essential company information such as the product you offer, terms and conditions, or FAQs, for example. So now imagine a customer seeking to cancel, a holiday package or upgrade, to business class, for example. Providing optimal support in these scenarios requires more than just the immediate, data on hand. So here is where the RAG methodology or RAG framework becomes invaluable. So RAG stands for Retrieval Augmented Generation. It's basically a technique used to enhance the performance or to augment the performance of a large language model by dynamically retrieving external documents or data relevant to the query or task. So, for example, I've mentioned here vector database, right? It's something I have not mentioned before. I believe most of you know about a vector database is. But a vector database can leverage the RAG by acting as the backend system that provides the necessary vector data. I'll define what that is. So very briefly, right? So a vector database stores data or documents, right, as numeric vectors, right? That's what a vector database does. However, by doing so, it allows semantic search. For example, if I have a document stored about smoking policies or in a restaurant, right? So I have these smoking policies in a restaurant. But then if I want to do a search in my vector database and I mention the word cigar or cigarette, the vector database will be able to correlate the word smoke or smoking with cigar or cigarette, right? And then return the smoking policy. So that's what a vector database does, this semantic search, right? You do not actually need to search for the exactly words or sequence of words or phrase. No, it's just semantically searching the documents. And the synergies of RAG, in vector database is fundamental, for in leveraging the LLM, the LLM model to provide rich, informed, and contextually aware support, for use case like that. In our demo, we'll see in action a vector database and how important and relevant that is. And when we put all of that together, by incorporating a data stream platform into the ecosystem, surrounding LLM, application, it enhances the capability by providing real-time updates, user interaction tracking, event-driven response, enhanced decision-making, and overall ensuring that the system remains agile and responsive to the ever-changing business environment. However, just to make that point clear, a data stream platform focuses on the real-time ingestion, processing analysis, and sharing of that data as flow through your system. But by doing so, it ensures that the most up-to-date information is available for immediate use. And on Confluent Cloud is the SaaS version or the fully managed version of Apache Kafka. So we have integrated Apache Flink in our offering. Apache Flink is another open source project as part of the Apache Foundation for stream processing, right? I mean, and with the offering that we have on Confluent Cloud with Flink, it's now what we have is evolved, to support a broad range of AI and machine learning capabilities, enabling users to leverage real-time data from intelligent insights and real-time actions. And this initiative, to bring, Flink into Confluent Cloud and to integrate with machine learning model, we have that natively. We're building that natively into Flink on Confluent Cloud. And one of the key aspects of this integration is the support of the use of public machine learning API or customer deployed models, that accessible through endpoints, platforms such as OpenAPI, ChatGPT, or GCP Vertex, or AWS SageMaker, for example. So this approach ensures that the forward compatibility and enhance partnership opportunities by allowing the users to leverage diverse range of machine learning use case. For example, from fraud detection to forecasting and text embedding using the machine learning platform of your choice. So now let's see a better example of our original question, right? Let's say I have again my customer on my application. And again, I'm a very wealthy and important customer that will come to my application. And my application this time will have access to the freshest information about the customer, the relevant information. So what can I do with the prompt? For example, I still have my initial question here as this. However, my application was able to inject additional context in that prompt. Like, for example, the first one is information to the LLM model or how it should behave. It's saying here, you are an AI assistant for a financial institution. You must comply with the following policies, blah, blah, blah. And the customer service guidance, blah, blah, blah. And we have a new query from our customer, Mr. John. He is 55 years old. He owns his house. He has a credit score of 715. And he asked, the following question. And the LLM model will be able, based on that, we will be able to provide a much better and rich experience to the customer. Because now the LLM model has the information or much better information, much more context to actually provide a better answer. So as you can see, it's it's a very different interaction with the customer because now it has the context it needs. And let's see some, sensitive use case, right? For example, when we integrate a data stream platform with large language models, it opens up, to several different, use cases, across different domains. So this ability, to process and generate human-like text in real time, reviews new opportunities, for enhanced, user experience, and automating, even complex tasks. So, for example, on let's see one example here on the supply chain or social media, right? Social media monitoring. So, for example, you can process and analyze social media streams to identify trends, sentiments, or even harmful content. You can prevent in real time content to be posted or not, depending if they are harmful or not, according to the policies of your social media, or even the policies of the country where the social media is being used to, right? Or even automatically responds to inquiries or comments on social media platforms on your platform. So those are just some examples of what you can do with generative AI and having the most up-to-date and relevant information to serve the model. So with that, we come to our demo, right? We're going to do a demo here of a chatbot for a restaurant. And that demo is publicly available. You can see that the link on my GitHub. If you go to my GitHub, Nesi, one of the repo is this chatbot restaurant. It runs on Docker. You can run that on Docker. You can run it for free or not. I'll tell you what's the difference here. So, for example, let me show first let's say the high level view of the architecture of this demo. So I'm going to have here my customers. I'll have my front-end application here, right? My chatbot web application. I'll have Confluent platform here. In the case of the demo, it runs Confluent platform running on Docker, where we'll be receiving all of that data, serving the data in real time. I'll have an admin plane. The admin plane is just, let's say, the admin of the application pushing data through the Confluent platform so it can reach my chatbot service, what data it is. We'll see that in a bit, but it's the policies of my restaurant, the guidance of how to serve the customers, the menu, right, of my restaurant, and any other relevant information. And I have here on my backend service, I have a chatbot microservice. And also in that chatbot, I have a vector database. In this case, I'm using a Quadrant vector database. I'm using Quadrant because I can have Quadrant running in memory, like a vector database running in memory. For this chatbot, it works fine, right? I do not have millions of documents to store, and just have a few less than 100 documents to store here, so it's fine. And the LLM models I'm using is Grok Cloud, which was developed by X, and OpenAI, right? Grok you can use for free, and OpenAI you have to actually pay for the service. If you want to run, I mean, Grok, it runs okay, but sometimes it might time out or might not, give the answer because it's available for free. If you want to do, a true experience, you can use OpenAI. By default, on that repo, you're going to use Grok, but there's in the details of the demo, you can see how to change to OpenAI. So now let's do a demo. Before I do the demo, let me show you, for example, the documents I am storing in that admin plane, right? This admin plane, those are the documents that produce. Like, for example, the AI rules, right? The rules that the AI must follow. The customer profiles as well. I'm storing the customer profile in memory in my application, but that could be in a database, no problem with that. I have here the kids menu, the main menu, the restaurant policies. I have details about the restaurant. And also I have informational documents that will be stored in a vector database. And you say, okay, why exactly do I need a vector database? Why do not pass all of that information in the moment I submit the initial question from or initial prompt from a customer? Well, there is where not the problem, but the way model works, right? So for example, here's my application, right? My Streamline, restaurant. I'm gonna log in here. I'm gonna with my customer Noah. Let's pretend I'm Noah. And now, what's happening here? I was greeted with a nice message. Welcome to Streamline, Noah. In fact, it's called Noah because it's one of the profiles to say his allergy or not. So it's no allergy, right? Very funny here. But Noah, right? He has no allergy. And say, okay, we're delighted to have you with us here. If you have any question or if you need assistance, feel free to ask. Okay, nice. The application knows my name, know who I am, So, but what happened in the background? If I come into the logs of the application, you see Noah has logged in. I have the information about Noah, and that's the actual context. All of that is the context that I'm passing to my chat, to my LLM model, right? I have here. You must comply with these AI rules, details about the restaurant, restaurant policies, the main menu, the kids menu, and in the end, I pass this. We have a new customer. Name is Noah. He's 35 years old, allergic to nothing. Greet day with a welcoming message. So the chatbot receive all of that and say, hey Noah, that's thank you for to come to us. But if you see here, number of tokens, 2,403 tokens in a nutshell is basically the number of words I will pass to my model, right? Basically, roughly speaking. In fact, when you interact with the LLM model, when you submit your prompt, the model will break, the words in tokens. Some words might be more than one token, but don't worry too much about that. But the way is, the more information you pass to the model, the more you're gonna pay in general, right? So you see, I pass all of that. Of course, there's much better ways to improve that model. I'm passing a lot of information here. For example, do I need to pass the menu? Not exactly. There are ways, and that's where it comes the prompt engineering, how to best make use of the interaction with the LLM model in the most effective, technical and cost-effective way. Okay, but now let's say I'm gonna ask here, okay, hi, thank you. Can I have a cigar here? And I just ask that and say, okay, smoking is only permitted in designated outdoor areas. Right, so let's see what's happening in the background. In the initial information I passed here to the model, there's no information about my smoking policies. So what I did, in the moment I asked that, can I have a cigar? The application, the backend application, will actually query the vector database. And as I said, in the presentation, okay, cigar, and that is my policy that was able to find, right? I have one specific policy here, which is the smoking. Where is my smoking? Somewhere here. If only I can find. So I'm pretty sure everyone else already spotted, but me, smoking. Here it is, the second one. So smoking. So I did a search, a semantic search on my vector database. It come up with this document here, smoking. And I injected, when I submitted the question to the prompt, I also injected that, smoking, additional context, smoking. And then my restaurant now says, okay, you cannot smoke here, right? I mean, it's not permitted. And then if I say, okay, okay, no problem. Can I, or let's say, can I book a table on the 25th of December for a party? Let's see what I'm going to say. For Christmas Day booking, I didn't mention Christmas, but it correlated 25th of December at Christmas. And if I come back here to the model, see, 25th of December, again, before I submit the prompt to the model, I did a search on my data stream platform, or my vector database, sorry, and it came with this policy, right? I have one document about Christmas Day booking, another one, well, not sure that's how relevant it is, maybe because I mentioned party here, and it found somehow found that relevance to that all the documents, but I submitted that to the model, and the model, was able, to say about Christmas Day booking, etc. And then I can go on and on, right, with that. If I come back here to the model, so all of that, right? So every question I ask, it goes to the platform. The question itself goes to Confluent platform in a topic in what we call the CQRS pattern. It's CQRS. It is command and query responsibility segregation. Basically, in a nutshell, is you submit a query in a topic and get the response in another topic. So a data stream platform use topics to the way you're going to store, store and serve the data. So every question comes to the platform. The chatbot, in the moment it bootstraps, will get all the information that the admin plane pushed. So you get that from the platform. So it's able to replay, right, the events. Some of the events will push to the vector database, and some other will keep in memory. So the request will come here to the chatbot. The chatbot, if it's the initial question, will push the information that has in memory as part of the prompt. And then any other question, any subsequent question within the same session of that user will query the vector database to inject more relevant context. And then I could continue on here on the demo, asking questions, getting the menu, or asking for my bill, whatever. But I think for the purpose of what I had to show here, I think I finished what I had to do. It is to show how to bring the relevant information to your application, right? In this case, my backend application.